My name is Guy Gennon. I am the Harold and Kathleen Fott Professor of Mechanical Engineering at the McKelvey School of Engineering at Washington University, and I am co-founder and Chief Technology Officer of Cayley Vascular. Cayley Vascular is a company that began with conversations here on campus between the Center for Innovation in Neuroscience and Technology and the Center for Engineering and Mechanobiology. This is one of the only ecosystems in the world where conversations like this can happen. What we do that nobody else does is use what we call sequestered therapies. We have a system for trapping a blood clot in a specific region of the vasculature. We call it the hydrocatheter. It stops the problem of distal embolization, as it's called, meaning parts of the blood clot traveling down to the rest of the body. The death rates for a patient with a deep vein thrombosis or a pulmonary embolism are very high on the table right now. We aim to save lives.
I'm Mark Meacham, Assistant Professor in Mechanical Engineering and Materials Science. So Open Cell Technologies is a life sciences tools development company, developing what would be categorized as intracellular delivery. And the device that we use is what's broadly termed an acoustic microfluidic device or an acoustofluidic device, which is a combination of using acoustics or sound waves inside of small fluidic channel. It turns out that the process of using that acoustic wave to drive the droplet generation can also be used to apply a very controlled deformation to biological cells as they're also sprayed out of these microscale nozzles. So that is the sort of force or action that we put on the cell to cause them to open their pores within their membrane.
The St. Louis startup community has been remarkable and has been extremely supportive, extremely generous in terms of funding, in terms of advice, and in terms of helping us recruit world-class executive talent.
It's easy to form a company on paper. You know the technology really well as an engineer. It's those little things that you don't think about. Oh, I have to make purchase orders to order things from a company. I can't just talk to my finance person to make a, you don't understand until you start doing it how much work that is. So,
an engineer brings a crucial skill set to the design of surgical devices. There's an engineering approach to understanding a problem and to understanding the many variable ways that you can break down a problem into its fundamentals, absolute essentials, and then identify which amongst your many ideas might be most promising. At Washington University, we actually have a formal system for this. This is at the Center for Innovation in Neuroscience and Technology. We bring together surgeons, engineers, and basic scientists and look at some of the most important basic questions, then link that together with engineering approaches and engineering solutions. Engineers, regardless of their background within McKelvey, are taught how to innovate, how to communicate across fields, and how to apply basic principles to make transformative solutions.